So in today's video, I'm going to talk about LLM confidence. In particular, I'll talk about two recent papers, one called ARPO and the other Deep Think with Confidence. As a prelude, I'm going to go back and talk about some of the things which were circulating around the time o1 was released by OpenAI. Hopefully, understanding these kind of ideas will give you an intuition about how this research came about, and also the scope for experimenting with these things yourself. So back in September 2024, OpenAI released o1 with this blog post and also showing off the model. This was an extremely exciting time, but of course everyone was interested, how are they doing this? So shortly after o1 was released, I talked at the Machine Learning Singapore meetup about how this might be happening, with a whole presentation here talking about the different things which might be going on. So my presentations at the meetup weren't videoed, but I'll give you a very quick catch up now, and so we can lead through to the research which has just been published. So one of the theories that people had about how o1 worked traced back to work done in 2023 at OpenAI, Let's Verify Step by Step. And in this work, they traced through mathematical proofs in a stepwise fashion, trying to get the model to figure out whether or not it had improved its odds of finishing the proof at each step. And so this paper showed the benefits of having a process reward model, which is looking at it step by step, as opposed to an outcome reward model where you only give a reward for the final answer. This is a figure from that paper in which you can see that either majority voting or the outcome rewards essentially flatten out in terms of performance as you apply more scaling at test time, whereas the process reward model keeps going up and to the right. And so this was a very interesting result. And the paper further fueled the idea that there might be something interesting going on with this sentence: "We consider this a compelling direction for future research," which people took as an indication that they'd already found something compelling. As an aside, one slide I had in my previous presentation pointed out like a slight problem with o1. So this was OpenAI's much touted test time scaling observation, showing how you could improve performance by adding compute. And that in itself is an interesting observation. However, touting this as being a log linear scaling is actually the opposite of what you want. Really, you want an exponential linear scaling, or even a linear scaling. Showing this log linear scaling is really claiming that to get a plus X% of accuracy, we need to do twice as much compute, which is essentially saying you can get as much accuracy as you want by burning exponential amounts of money. But even so, people were very excited by this graph. Another thing which I found interesting was this physics of language models tutorial at ICML in July of 2024. Now in this, one of the interesting things, which I had also already been exploring, was the fact that LLMs kind of know whether they have made a mistake once they've emitted the tokens for that mistake. So they may not know ahead of time that they're going to make a mistake, but after they've outputted some bad tokens, they know they're in a tough spot. So this is kind of an interesting thing which could possibly guide like a reasoning trace. So my super simple idea from early 2024 was do-over training, where essentially we'd look at the observation that these things know that they're doing something wrong. Maybe we could train an LLM to say whoops after it makes mistakes. And we could then make a data set of mistakes followed by whoops, followed by the correct answer, which essentially would allow the LLM to backtrack, or learn to backtrack. So by September, other people have published similar ideas, so at least I knew I was in good company. On the other hand, that didn't really answer what is o1 doing, which was top of mind for everyone in the field. Now another line of thinking, which kind of went wild on Twitter, was Entropix. And some of the key people here I think were Doomslide, aka Frog. There's also Shrek. There's a bunch of people very involved in having a look at the entropy of the distribution of token output to try and figure out what the LLM was feeling at the time and whether they could guide it in different directions. And Twitter being Twitter, this turned into a meme fest. On the other hand, there was a repo of code, there was clearly serious work being done, and people were just wondering, okay, what's going to come of this? To go back to the outline, I've talked about the O1 launch, the iSimul tutorial, Entropix. The news here is we've got signs of life of Entropix-like methods, ARPO and Deep Think with Confidence. So I'm now going to go through those two papers. So the ARPO paper came out in July of 2025. It stands for Agentic Reinforced Policy Optimization. And the idea here was based around the fact that LLMs show spikes of token entropy right after using tools. So we could use that as a kind of insight into what's going on, to guide exploration, and also to try and estimate how well we were doing as we're rolling out. They published a code repo, and I'll link all of this in the description. And the paper is on arXiv, so everyone can read this. So taking a snapshot from the first page of their paper, you can see here a graph of the entropy of the tokens following various calls to tools. So this is a whole agentic thing. They're trying to figure out, does the model like the tools which have been called? How surprised is it after it receives tool feedback? Are the tools giving it back out of distribution kind of tokens? And then using that to kind of guide whether we should be using this as a branching point in a rollout strategy for learning how to do agentic stuff. So you can see here from the top that the entropy is highly variable. So what does it mean? So for the entropy here, we're looking at the distribution across all tokens being output at every step. And a high entropy would essentially be all of a very even distribution amongst all possible tokens. Whereas a low entropy would be a very certain output, so that essentially the LLM knows what it's going to do next. So you can say that the low entropy is very, very settled, and the high entropy has a large degree of variability, which indicates uncertainty. So the results shown in the paper are very, very attractive, though I think we have to be careful about how many rollouts we're allowing ourselves, whether it's pass at 1 or pass at 5. But clearly this ARPO method is showing some advantage by measuring the uncertainty in the LLM's outputs to try and gauge whether it should be tool calling, how it should be branching. And from the graph at the bottom, we can see that ARPO learns to be more efficient with the tools it calls. Switching over now from the agent setting to one which is more about LLMs for mathematics, this is Deep Think with Confidence, which is a meta paper from August of this year. This got way more attention on Twitter, and in particular drew the comparison with Entropix from the year before. So in this method, they take the confidence to be essentially a fixed window moving average over the negative mean top K logprobs. So basically they're looking at the degree of uncertainty over a moving window as we go along. So rather than looking at the entropy of each token, they're looking at a confidence measure which is the sliding window of the top K, which are the most probable tokens. But here what they're doing is they're trying to find out how unlikely are the most probable tokens, i.e. how unconfident are we that the correct answer is in the top K. Now this is also quite easy to calculate and easy to deploy, and they've made a pull request into vLLM of about 50 lines of code where you can then have this as a flag. We can switch it on in vLLM to actually pull out this as a measure. So Meta has a nice project page for this paper which links to the paper, the vLLM code and some examples, as well as the results, and they have kind of a nice animation. So playing through this animation, it shows a bunch of trajectories for some mathematical reasoning. Now what we can see here is each of these trajectories, if it remains confident for the whole way until it gets to the tick, or it gets to the place where it decides to finish, now we have some endpoints for these trajectories. On the other hand, there are other trajectories here where it actually ends in a low confidence kind of trace and just gets eliminated. And so what they're doing is they track for the ones where it remains confident until it gets an answer. They then take an average over those to determine the actual answer being presented back. So here, the reasoning outcome, rather than being just a plain majority vote, is essentially weighted by confidence, and they show that this is a very effective way of getting to the right answers. So they also link some code which implements their method, and in particular they show how this can be embedded within vLLM. And if you don't want to just use their pull request directly, they actually show you how to copy paste it into your own local copy of vLLM in a step-by-step way. So as I mentioned before, there are some very encouraging results on the AIME 2025, a hard maths exam. And here they're showing extremely high performance at 99.9% for this deep conf at 512. Now the model they're using here is the OpenAI open source models. These are good models, but clearly enhancing it with this kind of confidence measure can increase the performance even more. So as kind of a summary here, I'd say yes, this thing definitely works. There is a performance boost. They say it's ultra efficient, which reflects the number of tokens being generated. On the other hand, this is achieving the 99.9% accuracy with 512 rollouts. So I would kind of question whether doing this number of rollouts is real reasoning. From a results point of view, you might argue that anything which gets us to the right results correctly is good reasoning, therefore we've made a good reasoning model. On the other hand, I'm pretty sure that if I were doing AIME questions, if someone saw me taking 500 separate attempts, they would reasonably assume I really didn't understand what I was doing. So in that sense, maybe this isn't the real reasoning we're looking for. So, to wrap up, these research ideas take some time to brew. There's an aside I have with this doomslide tweet. And so here, Frog is saying that he's very happy that this result has finally come out, for work which they'd been exploring maybe 10 months earlier, but also saying that this Entropix thing has been a bit of a millstone where there's been so many other things to investigate, and people keep drawing Frog and Shrek back into this what is happening with Entropix question. So the second point is yes, this thing actually works, and it's going to be in vLLM very soon. And lastly, I'd say that this direction has proven to be fairly accessible. While it may take large resources to be doing 512 rollouts, the basic idea or the basic principle doesn't need very many evaluations to see whether we're on the right track. So the question then is, what other directions are interesting and what else could be explored? Thanks for watching. If you'd like me to cover more of these reinforcement learning topics, or maybe agents or RAG, I'd be very glad to read in the comments what you're interested in. I see this YouTube channel as being an opportunity for reinforcement learning in real time, since trying to judge what people are interested in and then getting measured on view time and all these other statistics makes it for a very interesting problem. If you can help me out by commenting to let me know what is good, that would enable me to direct things in a much more beneficial way. So, looking forward to that. See you next time. Cheers.